Hello. In our previous video, we went through the other theorem, that is the angle subtended at the center by a chord or an arc is twice the angle at the circumference. Today, we want to move on to this particular theorem, which states that angle subtended at the circumference by a diameter is always 90 degrees. So let's assume that we have our center, so this is our center. Okay, and then we have our diameter, so this is our diameter. So the angle that this diameter will be having at the circumference. So assuming that we have this. So the angle that we'll be having at the circumference, that is this angle, will always be 90 degrees. It can be like this. The angle that we'll be having here will still be 90 degrees. It can even come down like this. The angle that we'll be having at the circumference is 90 degrees. So that is how this theorem works. The most important thing, we have a diameter. So this becomes the diameter, and we are having an angle that the diameter is subtending at the circumference. So this will be 90, this will be 90, and then this will be 90. Okay, so let's consider an example on that. So let's assume that we are having this question, this particular one. The question wants us to find angle ABC. If you look at the line AB is a diameter because it is passing through the center. We assume that this is our center. If that is the case, then the angle that we are having at the circumference, that is the angle at C, is 90 degrees. If that is the case, then considering triangle ABC, the total angle there is supposed to be 180 degrees. If the angle at C is indeed 90, then the angle at A and then the angle at B will sum up to 90 degrees. If that is the case, then the angle CAB plus angle ABC, this is supposed to give us 90 degrees also. If that is the case, the angle CAB was given to be 55 degrees. So this is 55 degrees plus our angle ABC, and this will be equal to 90 degrees. If you are solving for ABC, then we are going to have our angle ABC to be equal to 90 degrees minus the 55 degrees. And indeed, this will give us what, 35 degrees. So that is how we can find the angle ABC in this particular one, that is the angle marked X. Let's consider the second example. In the second example, the question wants us to find angle PRQ. Again, if you consider the line PR is a diameter. Therefore, the angle that we will be having at the Q, that is this side, is indeed 90 degrees. If that is the case, again, considering triangle PQR, the sum of the interior angles is supposed to give us 180 degrees. So if this side is indeed 90, then this angle plus this angle will also give us 90 degrees. Therefore, we are going to have the angle QPR. So angle QPR plus angle at R, that is angle PRQ. This supposed to give us 90 degrees. Okay, so now we can say that 3x minus 8 plus the 2x minus 7, this is supposed to give us 90 degrees. So that 3x plus 2x, this is going to give us 5x minus 15 being equal to 90 degrees. And we're going to have our 5x to be equal to 90 plus the 15. So we have our 5x to be equal to 105. We are solving for x. So we divide both sides by the coefficient of x. So here by 5, this by 5. And we are going to get our x to be equal to 21 degrees. Okay, now the question wants us to find angle PRQ. And this is the angle PRQ, the angle here. Okay, so our angle PRQ indeed is 2x. And what is our x? X is 21 minus 7. And this is going to give us 2 times 21 is going to give us 42. So 42 minus 7. and this indeed is going to give us 35 degrees. So the angle PRQ is equal to 35 degrees. Let's consider another theorem. All right. So for that theorem, it says that angles subtended at the circumference by the same chord or arc are equal. Now, how do we understand this theorem? First, let's assume that we have a chord. So this is a chord, all right? And this chord is having an angle at the circumference. So let's say we have this angle here. And let's assume that this same chord, let's say the chord is AB. This same chord is also having another angle at the circumference at different point. So we have it like this. Okay. Now, this theorem is saying that the angles at the circumference by the same chord are equal. So it means that if we are to consider this particular arc or this particular chord, the angles that they are having at the circumference, yes, we are having one angle here. So let's say this particular angle is theta. And again, the same chord or arc is also having another angle at the circumference here. And let's say that angle too is alpha. Okay. If it happens like this, then it means that the theta is equal to the alpha. That is what this theorem is trying to take. So even if we are still having another angle like this, the most important thing is, yes, this angle at the circumference, that is whatever angle that we are having here, is being subtended by a chord or an arc. So if this is, let's say, small a, then this one too will be equal to the a. So that is one thing about this particular theorem. So let's consider an example under that. In our previous video, we did solve the same question, but we did solve for the n, the value for n. So this time around, we are not solving for n, we are solving for m. Let's consider this arc, RQ. Now ask yourself, this arc, is it having an angle at the circumference? Yes, it is having an angle at the circumference. That is this particular angle. The same arc, RQ, is it having another angle at the circumference? Yes, that is M. If that is the case, then we can conclude that indeed the angle at S is equal to the angle at P. In that case, straightforward, we can say that our M is equal to 32 degrees. It is as simple as that, because these two angles are being subtended by the same chord or arc, and that is this particular arc. Okay, let's consider another example. If we look at this question, and this question is a combination of the previous theorem and then this theorem. Now the question wants us to find angle PRS. And if you look at the diagram, then we are referring to this particular angle, that is PRS. Now for us to find that angle, the angle at R, we should bear in mind that QS is a diameter, because what we are having here, we are assuming that this is the center. So if this is a diameter, then the angle that this diameter is having at the circumference, at this side, is 90 degrees. Okay, this is 90 degrees. If that is the case, then we can say that if this side is 90 degrees, then this side is going to be 40 degrees. Because 40 plus 50 plus this 90 will give us 180 degrees in that triangle PQS. If that is the case, then we can say that the angle PQS will be equal to angle PRS. So if PQS is equal to 40 degrees, then angle PRS indeed will be equal to 40 degrees. So this is where we end today's teaching. Now watch out for the next video on the next theorem. Thanks and bye-bye.